All right, I'm back. I think we'll just get going. We'll get going here. I've got a room full, so I don't want to tie up anybody's time. Just a precursor. I am going to go through a fair amount of information and options. We could probably do a webinar on each one of these options and styles of attenuation. So view this as a precursor, give you a lot of information, a lot of things we can do. And then in the future, we're probably going to do some webinars on some of the more specific, more detailed solutions and the higher attenuation models, because each one of those really, in fairness, could be a full half hour understanding some of the things we're going to go through as far as airflow, pressure drops, attenuation, etc. So with that being said, welcome. This is really all about standby power, not so much power generation. That's a different world as far as transformers and steam turbines and things like that. This is standby packaged power. So what we're going to run through is, and I'm going to leave this up as a slide so you can see the slides on the side, because there's a lot of information before and after and leading up to things. So I wanted you guys to be able to peek or be able to look back at something. I know you can't see it that great, but it's worth value there, that it's not just a slideshow that you're only seeing the slide. I'd like you to focus on the big one, but there's some value in the others. What we're going to touch on is several solutions rather, utilizing our standard products, whether it's the quiet line, stacking rather straightforward barrier systems, or introducing and using our quiet mod, which is our standard 4-inch panel system, for which we have, I think we're up to about 14 different product panel models for various attenuation levels. So it's the combination of the two. We're going to talk about these babies on the right, the packaged engine sets, whether it's a standard open on a skid all the way through the offerings that the manufacturers provide, and then how we can enhance those when needed. So key to it is, it's chicken and the egg. One is I need X attenuation at a property line, and I'm going to be putting a genset X feet away. Well, you kind of need to know what the heck the genset is that's being proposed, how they're planning on providing it, and what shape and condition. We'll touch on that. And then knowing that, you have to understand everything about that generator. Then you can kind of pick your best solution. Ideally, this is done at the design phase. I'll be very honest that most of the times we use the very first option here, which is a quiet line barrier. It's a retrofit. It's happened. Somebody already put it there. Now you guys are getting phone calls about the problems when it starts up. So I'll run through a quiet line barrier fairly quickly, because that's fairly straightforward, common to all of you guys. Then a barrier that could be enhanced a little. I write here with baffling. We do some open air things with the barrier, still not going to a full enclosure for cost and other reasons. Then we go to a quiet mod. I call it the entry level enclosure. It's kind of very specific for a genset engine that's just on a skid, doesn't have its own enclosure. Usually it's inside a larger facility, and we're partitioning off part of that facility or enclosing the power equipment within a facility. Then there's the complete enclosure. That's where we build an enclosure to sit outside, bring all the air in, take all the air out, and meet the attenuations levels of whatever your need may be. And then the max is that enclosure really tuned up, where it usually gets very custom intake and exhaust air systems, and typically like a double wall panel system. So they get very significant, but it's for extremely demanding attenuation levels, which I'll again hit on briefly, but there really are like 4 or 5. So you kind of know your engine, you know your parameters, then you can really look at, what's my best solution, best bang for the buck, and what gets me my attenuation. So on that note, when you find out you have a standby generator problem, I start to look at a few things just to get your hands around the beast. The engine size. How big of a standby power are we talking about here? A little package, Kohler unit, or a cat 2 meg monster. Once I have that, I'm starting to think about what's the airflow that's required, and I circle that. That's this ACFM of what that genset needs to flow through that enclosure, if you're building an enclosure, or if it's already in a package. It needs 60, this case, it needs 60,000 feet of, 60,000 CFM of air, excuse me. And super critical, the other circle is the 1/2 inch water gauge. So 1/2 inch pressure drop max. When we're designing one of these, we really try to even stay way short of that, because these prop fans on these gensets, if I'm using a connected radiator system, is not really tolerable of much more than a 1/2 inch. So we try to make our entire system more in the 0.4 area, and we'll get to that. But that is a key component. Why I circled it in red. You have to have that understanding of both the required airflow and the pressure drops before you start picking your solution. Another facet of that is the genset will come either packaged with what they will call a noise enclosure, or a weather enclosure, or in this case you see on the far right a soundproof canopy. You have to be very aware of, and I'll touch on this in the next slide also, which one of these they're using, because every factory enclosure, they can tune these up pretty well, but when it gets to a severe application, they can't tune them up enough. That's kind of where our strength is on the max enclosure, or some of the other options, the minimal noise control and the quiet line. But you can see a couple of things I circled here. You have to be careful when you're looking at their data, because they mix and match a lot of different distances in what the data is to look better, to sound better, to show a number that's tolerable to most of you guys who are trying to hit a code, or a customer that's trying to hit a code. So the language is a little loose, and it's common among all of them. It's not any particular guy I'm pointing out here, but down to 75 or about 75, and then at 10 meters or 1 meter, or sometimes 21 feet. It's always something different. So it's always a little tripwire, but something that I check after I take care of the CFM, I take care of the pressure drop, and if I'm dealing with a unit that already has an enclosure, what is their data telling me? And I inch my way a little forward. So this particular case, and this is where I highlight, read carefully, this guy is 7 meters and it's 86 dBA. So you have to start pulling that apart, because a lot of the situations we have, we're trying to meet criteria to a noise level of 3 feet, 1 meter from the enclosure. So we kind of have to work backwards. But you can see this case it's pretty loud. It's a pretty loud system that this particular customer was buying. So you have to really understand all of that, and then you can jump into, now what do I need? So the very first option, and again, we're probably going to have webinars on each of these, because I could really drill down on each of these topics, just giving you a good overview that we really are a full range attenuation supplier, from very minimal passive barriers all the way through a high end. We do it all. We manufacture everything, all of the components, and handle all the engineering for the air system. So with that said, the first step is a barrier. Somebody put a package unit up and it's not quite there. I got a problem at the property line. I'm missing by 10, I'm missing by 7, that kind of thing. It's the most cost-effective solution. It's the quiet line, either the V-stack, which you see at the bottom here with some louvers on top, kind of a unique application, or the SLR, which you see on the upper picture, which is the cream colored wall. The generator is obviously behind both of these. On the one in the white, you might say, wow, that's kind of a short wall for a generator. Right on the other side of our wall, we built that on a concrete knee wall, kind of a pit situation. So the top of the generator was equal to about the first panel in this situation. I just don't have a picture, couldn't get around the other side to really give you that scale, but that's why that wall is only 10 feet tall, because the genset's recessed much lower. At a hospital and all the communities off to the right. Same with the one you're looking at. It's great for 10, squeezing it 15 dB, where you can feel comfortable doing that. Very effective at a property line if you have line issues for that kind of attenuation needed. Super easy for maintenance into the genset. You're not doing anything around their enclosure or off their skid. So usually the genset manufacturer has no issue with it. Easy on the customer. And based on the layout, you can, if you say you go with a 4-sided barrier, it introduces a new aspect to some of this power distribution. Standby power is, it puts security around your unit and your customer's pad or access to whatever maybe power systems they have in there. Here they put the transformer outside. That could go inside the barrier wall as well. You'd have a lock access control into that pen where all of their electrical equipment is secured and out of public eye, really, out of public viewing. So that's just an enhancement if you do close off like 3-sided against an existing building or go 4-sided, it does give them that extra piece. The barrier, you'll see on the right, that's actually a temporary barrier. We've done a few of them now because, you know, picture's worth 1,000 words. Some people have seen that and it uses it, especially when standby power is brought in. In this case, you can see it's on a Caterpillar unit on a semi. So they put this wall up when they were doing a bunch of work there. I've had it done for seasonal work. It caught on quite well, but that's a basic application. This particular case needed 10 dB on the other side of the parking lot, which they achieved. Straightforward columns, foundations, our typical base plate detail. All these panels slide down between the columns, no fasteners, and you know, many different configurations are possible. Again, the real entry level gets you 10 dB, not really getting into the weeds too much, so to speak. Now, this is a barrier that still classified as a barrier because it's stacking panels and it's got an open top, but this is one example of a barrier with what I call a baffled roof and sound controlled inlets. The roof, 3/4 of it is slatted with a 10-foot deep baffle system. There's another picture here down below, right where my cursor is pointed. You can see there's 2 gen sets that were a problem child. I'll just jump down to that slide real quick. They were sitting out behind a resort in a Caribbean, and the whole hillside you can see off to the right is very high-end condos. These 2 beasts would fire up, and you know, the people's coffee cups would rattle on their tables. So they had to do something. This enclosure has a interior partition right where that roof cap stops, all the way down to grade. And you can see the little hoods on the left. There's a series of 2 rows. That's all louvered intake to feed the 2 front ends of the gen sets that you can see in that picture. And then the back half is the gen sets and the muffler, because these had no muffler. That's why this one was kind of unique. They had no muffler. They were just straight piped out of the gen set. So you can imagine what a 14-cylinder, you know, cat running away is. They were loud, loud, loud. So this let them not mess with, they didn't have the money to really redo the enclosures, get new gen sets. The mufflers they were needed were fairly expensive. People were always messing with their power and like tapping into it, you know, as a remote Caribbean island. They had all kinds of issues. And this really, back to the beginning, kind of like which one fits the best use, which gives them these various parameters. And it turned out that this one was the system to go with these 2 gen sets, which sit straight underneath those baffled, 10-foot baffled. So when it starts running, those mufflers were pointed straight out. Now they point straight up, and they would evacuate through those baffled ceiling system. In essence, we're building a giant silencer in the top of the barrier system. Still not a full enclosure. I'm not worried about weather protection, things like that. And the 2 units where they're sitting there are operating just the way they were sitting there before we did take off the front end intakes, but it tried to keep their costs down, and it answered a lot of things. We've done it about 3 times now, very successful each time, but it's a kind of a unique, like you can see here, very unique solution application. Then you get into the enclosure systems. There's really 3 of them as I see it. The one example here, usually interior. So we have a customer, you could see the engine sitting in there in that picture off to the right. There's 2 Cat engines inside a larger facility, and they didn't want to buy an enclosure from the genset manufacturer and, you know, have 2 generators sitting inside and then have to deal with going inside an enclosure. It was kind of a pain for them. And it was a remote radiator setup, which is important in this case because the radiator and the large volume of air that had to go through there to service the cooling from the radiator fan and radiator are outside. So they really just have 2 big engines running that need nominal cooling through that room, and the liquid cooling is coming from outside. So here is an example of an enclosure that's really, really just an enclosure with a few special attributes, whereas we in this case, incorporated a mezzanine. The mezzanine was there, and we worked around the mezzanine to assemble this enclosure. You can see the roof, ceiling panels. We worked within the mezzanine walls, gives them a window in, a door, kind of keeps it like an engine test cell. Nice clean engine room inside a factory that was doing a lot of other things off to the left and right. Didn't want to deal with it. I'll jump back. You know, we put in things like these large double doors here. So each one of these can just slide right out the back if they ever have major service, but they're large enough where they can wheel in a cart, and they put a little boom crane over each one of them, but they could take out a major part or release something. But if something big happened and they got to get out, they just slide them out through each of these large doors. Then there was a little access here. So that's really the standard 4-inch quiet mod. We're taking care of the noise, specialty VRs, doors, windows, all rated at the same level or above, and really not worried about air. This probably had only about 5,000 CFM of air had to go through it. So it was just handled with a simple axial fan and some silencers. The brunt of this was just basic noise control. We do this fairly often, usually with much smaller engines than you see here with these big twins, but it's all just a scale and when you're not dealing with the air. So that's what I call just a basic enclosure system. Then you get into the full systems, and this is where noise barriers takes on the inlet, the exhaust, the pressure drop issues I talked about, the attenuation needed. We do not do mufflers. So the muffler has to be rated to the level of my enclosure, or you're kind of defeating the purpose. But we work with the engineers and the designers, and then ultimately the engine supplier, you know, with what muffler they're supplying, so that we're not attenuating less than the muffler or more than the muffler. But in this case, you see a lot of double leaf doors for access into equipment in the switching rooms, and then a whole bank of exhaust mufflers and exhaust systems. This is a case where you're really banking, you know, half a dozen or a dozen gen sets into one big room. We do that. Not that common because it's, you know, that's quite an expense, but the big data centers usually don't have one or two gen sets, they bank them. So there's economies here where you're doing one large room instead of a single room. We take care of the weatherproofing on the roof. This is just a simple drawing showing how we lay this all out. We do all the engineering drawings. Each gen set sits in each one of these bays, and we provided the entire structure, the structural steel, the panels. We designed the inlet, which comes in through a I've got another drawing here. Nope, I don't. I'm gonna move off that. So this is the inlet plenum, which you see right here in this picture with this guy standing next to it. That just came in through very basic weather louvers, and then it's fed through the silencers, dampers. Gen set sat here, and these were 10-foot exhausts that you see in this picture right there. So the entire scope was handled. We knew what the attenuation level had to be at the property. In this case also, you can, I don't have a picture, sorry. Inside is just in gen sets on skids, no enclosure from the manufacturer. So they save that expense and that hassle. They can walk in and choose any one of these to service at any given time. They can run tests and see which one's doing well, all with one easy walk. So none of their equipment is covered. And that's kind of a, attractive in this situation. And as I showed up here, it's kind of very attractive for them to be able to walk into one room and look at what everything's going on with their backup power. So there's no partition walls between each one of these. They just run, each one pulls straight through. Again, accounting for the airflow and the maximum pressure drop. Again, that we try to keep it about 0.4, 0.5 is like worst case. That's a big barn style. Brunt typically, and the normal one most people are used to, is the single standby engine test cell. I'll address questions at the end, if that's okay. So this is a case of two individually packaged gen set enclosures. These are kind of unique. This one has a control room here. The air is brought straight down through the roof right here. We'll get to that slide. And then exhausted back out through the roof. And here's where the engine sits. Both of them are here. SCR is going to be between them, so I don't have to worry about anything, the muffler system, but the cooling is also outside, but I am forcing air through this particular one. You can see I'm providing twin tube axial fans to handle airflow that comes in through here, across the engine, into this plenum, and up and out. This particular case, we have a control room separate and out in front, so you could be in here and look into this cavity and into the engine room. Don't do that very often, but it worked out fine in this one. So this is for a single system. This is when we absolutely know, much like in the barn style, but here is where we're really tuning it to that specific engine, what its CFM is, what its pressure drop is, what the horsepower of the motor is, what's the heat buildup in there. All of that is, part of our design package. And these are snippets from, what our typical submittal would look like, 10 to 12 pages, multiple details that usually go to an engineering group for the mechanical side of it. This is, I'm just going to jump off. That's for the full end of the full systems. And now, just trying to keep this to a half hour. This is the max. This is when the genset manufacturer is not going to even pretend that he can provide an enclosure for it, because they do love selling the enclosures. I have nothing against them. They're, I don't mean that. But this is where you get to attenuation levels of, I need 45 dBA anytime this thing is running 3 feet away. I need 50 dBA X. And then you see, here's a specification where it says, the permissible sound power levels. This is a big lift. This was a special max application, I would say. And again, it's severe attenuation, demanding layouts, put right next door to an office building, right next door to apartment windows. It's got to be silent. So in that case, everything is going inside the enclosure. Typically, we get into a double wall application here. You could see that there's the inner wall, there's the outer wall. There's no way to get to some of these, what I call max attenuations, without getting into a double wall situation. And the muffler will be inside of our enclosure. We handle the thermal issues with that, because many of you, if you're in the standby power, backup power, the heat load from that is intense, but it stops any bit of radiating out of the pipe and really lets the true performance of what will be a really stringent muffler system be just the exhaust of the muffler. And you'll see that in the last picture. But that's another case where we would handle everything's inside. You're not going to have a remote cooling situation here. There's more attention paid to the air and heat load ventilation and silencing of that than almost anything else. At that point, the enclosure attenuation becomes the easy part. But that's something we do regularly, several times a year, to this, what I call max attenuation, really pushing the edge of it. Here, the level of our submittals and stuff, so that we make sure we're sharing everything with the engine supplier, the customer. This would be the breakout of this particular intake. This wasn't a very big engine, but it was loud. We brought it in through 2 louvered openings, and then it would go pass through this double wall, and then it turned. These silencer doors are removed for clarity. They lived in this chase right here, so the air came in, turned down through there, and then came into the room low at the bottom of the plenum. And then, it's an assembled, it looks simply like that. That's just an example of the detail to each facet. The fan bay in this case would get the same level of detail. The exhaust chase would get that same level of detail. Here is the picture of that, and you can see right here. These are residents. These aren't offices, and they had to be. We had to be 45 dBA about where this light post was right here. But you can see the whole muffler is right down the side of this enclosure here. Then it elbows and comes out the side. So the only exposed thing is whatever's coming out the end of that pipe. So we're not worrying about the radiation, sound radiating off any of the piping, the muffler casing, anything like that. We're giving the muffler a fair shake, and that muffler supplier is also meeting the same attenuation. And then here's how we'd handle that exhaust. The air's going through here. You saw in this picture, this drawing rather, we have the tube axial fans towards the base of that big exhaust tower. So it's sitting right in here, and then silencers above that and discharge out of weather hood. But this, anywhere you walked around this unit, within 3 feet around, you had to be 45 dBA when it was at 100% load, as you saw for the spec. So kind of in summary, it's the right application for the right need. We offer all those solutions and all that engineering, and we gladly work with the engine manufacturers, the MEP on the job, the acoustical consultant, And it's really to show that we can do anything from the very simple, let's put up a barrier, get our 10 dB, guarantee that, all the way to extremely stringent. We do everything in between. We manufacture all the panels, all the doors, all the windows, all the silencers. It's a complete system from us, so we're not relying on any subcontractors or buyout parts. It's 100% our envelope. So again, I'm probably going to break this into a couple pieces because I could talk about this enclosure right here for quite a bit in much more detail about the heat loading, the airflow, how we handled it, the muffler, probably be of interest to some people. And even the middle of the road one where we're just doing a typical engine package set to try to get 30 or 35 dBA and better than what a sound enclosure can offer from the manufacturer. So I will ask you guys if you follow up with an email with questions, because I had to keep this to a half an hour for a couple of reasons. I would love it. That's my email right there, or that's the phone number. You'll get Sherry if you call that, but she can get it to me. But an email would be best, and I would love to, it can simply say, give me a call, or you can ask a question. Either way, I'll take care of it. And maybe on some of the future ones, I'll have much more in-depth Q&A period, but I just can't do that today. So went through a lot there. You guys saw a lot of options. I hope it wasn't too much, but I was clear enough on each one. Again, it's really 5 options. What's the attenuation level? Minimal to max, and everything in between. So again, give me a call or shoot me an email if you want me to give you a call, and we'll go from there. Really, really appreciate you guys' time, and sorry for anybody a couple of weeks ago that I canceled out. And if any of you dialed back in today, really appreciate it. Thanks so much for your time, and look forward to helping you guys with any needs. Take care of yourselves. Bye.